Oh, God. Okay. Sorry.
I knew that Aaron build a cabin on the woods. She likes to make a road to the cabin, starting at the gate, going through the clearing along the edge of the woods, and then cutting through the woods to the cabin.
All right, so here we have, out here, we have a clearing. And here we have the woods. And essentially, you can imagine, it's easier to build a road when the trees are down than if the trees are there. So she has to build this clearing. And can you imagine a couple different ways of getting there? Like, can you imagine going, let's see, this route all the way along the clearing and then cutting down to the house? Advantages to that? Straighter. Well, not from the other way, just advantages to this. No, straighter, Ian? Less time through the woods. Okay, so it's probably maybe easier, okay, because you're going through the woods less, right? Because you don't have to clear the trees out. Maybe.
Better for the environment.
There you go. All right. Thinking green. I like it. Okay. You can imagine this route too, right? The blue route. Can you see that?
Yeah.
Okay. My eyes are going. Okay. What's the advantage to that route?
It's the most direct.
Okay. Alicia and Julie, I think it gets right there. It's straight. Actually, the hypotenuse of the triangle. What's the disadvantage? Cut down a lot of trees. If you look at the yellow one now, you see that it's straight and it doesn't go through the woods. Can you also see that it's a lot longer? So the yellow one's going to be longer. The blue one's going to be more direct. All right, so let's keep going. Morgan, can you read for us A?
The distance from the cabin to the point on the edge of the clearing closest to the cabin is 1,000 feet. The distance.
All right, hold on. That's not here. So wait, the distance from the point of the edge of the clearing closest to the cabin. All right, so that's this distance.
Yeah, so it would be that.
Is that okay?
Yeah,
All right.
the distance from the gate to the same point is 3,000 feet. Building the roadway costs $20 per foot through the clearing and $30 per foot through the woods. Write an equation expressing the cost of the road, see in terms of that.
All right, so it is more expensive to go through the woods. So here's the thing. Actually, once we get A, like B and C are just like doing calculus, and that's great. A is going to be hard. We need to come up with an equation that expresses the cost of the road in terms of this value X. And can you see that of all the combinations, the most general combination is to go a little through the clearing and then a little through the woods. That's a balance.
So wouldn't you want to go a lot through the clearing because it costs less?
I don't know. All right, so Morgan's saying let's go a lot through the clearing. Sam's saying go through the woods.
I mean,
Well, there's going to be.
well,
All right, we're going to figure it out.
If you take a smaller distance through the woods, you have to take a longer distance through the clearing. So I think it's going to still add up.
All right, David?
If you do the math going that way, the right angle way, we want the up and the over, is $90,000.
So it's $90,000 to go 3,000 this way and 1,000 this way? And you think that's a lot or a little?
Yeah.
But if you go 3,000 that way and 1,000 that way, you're not technically.
Well, what would the blue? How long is the blue? Let's just look. How would you find the blue path?
Pythagorean.
Yeah, Alicia and Julie are saying 3,000 squared plus 1,000 squared square root of that.
It's like 3,162.
3,162. Okay, and now I have to multiply that by 30. That's going to be more than 90,000. Okay, so we have 90,000 going the yellow route. We have over 90,000 going the blue route. Do you think maybe there's something in the middle that might be better? Yeah, something about the pink, right? And here, we'll do the math. And if in fact we're wrong, What's x going to be if the yellow root's supposed to be the right root? How long is x going to be? Say,
3,000.
what'd you say? You're ahead of me, I think. Can you wait on that answer for a second? All right. If the yellow root is right, how long is the x value going to be? X is the distance from here to wherever. All right, I'm asking the question really poorly. No, so if the yellow root's right, x is going to be 3,000. The problem's going to say, hey, x should be 3,000. Do all 3,000 here. If the blue is right, x is going to be 0.
Wait,
what is x supposed to be the whole, like, is x from the...
X is from this point to wherever you decide to cut in.
Oh.
I said that backward, didn't I? If x is 0, then that tells us, to do the, all right, Katie, I need your answer now. Sorry, I apologize. I should have asked for your answer first. All right, Katie, you were, I think, going to give me this distance right here. I'm pretty sure. Yeah. Okay, so Katie says, look, 3,000 minus x.
Wait.
For the pink,
For part of the pink, right?
like for the part of the pink before you go down.
Yeah. And Katie, can you just close? I think it's like an algebra 1 strategy, but just explain to us how you got 3,000 minus x.
Well, you just know that 3,000 is the whole thing and x is part of it, so the other part has to be the difference.
Right. Right. So x plus 3,000 minus x, that has to be the whole thing, 3,000. It is, isn't it?
Yeah,
Right. Can you?
They have to find the hypotenuse of that.
All right. So wait.
Square root of x squared plus 1,000 squared.
All right. Hold on. Stop. All right. You are going too fast. All right. So.
Sine function.
All right. Arnie's telling me that the hypotenuse. Go ahead. Tell me what it is.
What? So David's telling me it's not a...
No, just tell me it is.
Okay, so it's square root of x squared plus 1,000 squared. Oh, just that distance, yo.
All right. So look, Katie and Arnie. Right. We're looking at that triangle. Right. It's a right triangle. So Arnie tells us this piece of the pink is the square root of x squared plus 1,000 squared, and Katie tells us this piece of the pink is 3,000 minus x. So I actually have two pieces, and those two pieces are really important. And do you see how they're not totally obvious, but if you think about, Katie used some algebra techniques to find 3,000 minus x, Arnie used some geometry techniques to find the hypotenuse. Do you see how do you understand what I'm saying by when I say it's hard and why it's going to be hard?
Yes.
Okay, good. All right, thanks. Now let me think about the original statement that I made that I think was wrong. If x is 0, that means that the pink piece is going to be 3,000. So if x is 0, that actually says go all the way along here and then cut down. If x is 3,000, that says don't go along here at all. Go 0 along here and just cut straight through. All right, so x is going to be somewhere between 0 and 3,000, and our general sense is if it's 0 or 3,000, the walk's going to cost like $90,000, or maybe a little bit more. Is there something in between that's cheaper? I hope so. Drew, do you have a question or a comment?
No.
You sure?
Completely equation now.
Okay, so now we need... Go ahead, talk to us.
Alright, so you multiply the hypotenuse by 30.
All right, 30 times the square root of x squared plus 1,000 squared.
And then you want to add 20 times 28 to 2,000.
Awesome. Do people see how there are two parts to the path? There's the $30 part, and there's the $20 part. How we doing? Make sense? You okay? All right. David?
Fine.
Okay. We actually did what part A asked us to, and that was the hard part. If I gave you that equation, you'd be awesome at this. You'd be like, all right, I can graph it on my calculator and then take the derivative. I can do that. The first problem from tonight's homework, they're going to give you the equation. And you're going to be like, okay, this is great. This is easy. I can do this. And then the next, 3 problems, they're not going to give you the equation. And you're going to say, wow, this is hard. I have to do, rectangles and distance formulas and hypotenuses. All right, so we need to graph it. All right, let's take a look. We have 30 times the square root of x squared plus 1,000 squared.
Going from here to find the derivative of this, find a then back.
Don't you think?
Yeah.
Yeah. See, you already know what the strategy is. I love it. All right, so what's B say? Oh, so all right, sorry. B asks us to do it on our calculator, and then C says justify it. So we're going to do both. I love it. I totally forgot. Oh, what was this? 30.
What I just said.
Okay. Remember, we're trying to heal. Okay, so we need to show the love. We need to come together. We can do this. All right. Now, in order to get any sort of decent picture, I have to think about what the domain and range are. So I need to think about x values and y values. You actually have already started thinking about the y values. What's x a measure of in this case? Feet. So what do we think it's going to go range between? All right. I'm going to, whoops, hold on. It's a little too much. I'm going to turn my x scale to 0. Just because, if I don't, it's going to try to put 3,000 little tick marks. And you can do that. It'll just look like a really thick x-axis. And I already know, I doubt it's going to cost less than $0. But David, with some calculations, told me it could cost as much as, all right, I'll go $100,000. All right. We graph it. Oh, I forgot to turn this y scale off. Hey, it looks like there's a minimum value there. It looks like there's going to be a way to minimize this cost function. All right, what do you get? Still thinking. It's a tough function for the calculator to draw. I agree. You guessed? Oh.
Sorry.
That was not bad. Is this what you got? No one's doing it. Julia's doing it, and Alicia's doing it, and Morgan's doing it. All right, no one else is. That's okay, that's fine. I need someone to tell me that what I did was... We went 0 to 100,000?
No, but
Yeah, you want to make it 0 if you don't want to run
Gesundheit. Does that work? So, around 895 feet should be X, and how much is it going to cost? Whew. Man, it's expensive to get a road to your cabin in the woods.
maybe just this particular.
Oh, Anita. All right. No, I was talking to the problem. All right. So X should be around, this value should be around 895, which means from Katie's, this should be 2,105. So the best strategy is to go around 2,100 feet along the clearing and then to cut through the woods. That'll be the least expensive. There are people whose job it is, maybe not to minimize the cost of, this road to a cabin, but that's their job, is to minimize costs or maximize profits. And the hardest part of their job is not the calculus or whatever, it's coming up with what the model is. And that was the hardest part of our job. Ready to do a little calculus? All right, talk to me differentiators. I could.
Can you switch it to be x squared plus 1,000 squared quantity to the 1/2? And then do
And I can maybe even make this 60,000 minus 20x.
so then for the first part you get
Well, no, can you just be nice and take the 1/2 and put it in and get rid of it?
No! Oh, don't say that.
That's A squared plus B squared.
Wow, computations. Okay. Okay.
You get killed.
Back down.
get this to
You're assuming I'm
x
taking.
squared plus 1,000 squared times to the negative 1/2 times 2x.
I'll do the next part. Plus 0.
Oh right. Yes.
And,
Minus 1.
awesome. Thanks. Okay, so it looks like 15 times 2x, that's 30x. And this is all to the negative 1/2, so that puts it in the denominator. So I get x squared plus 1,000 squared minus 20. So there's my derivative. All right. Is it ever going to be undefined? When you take x and you square it, what do you get?
0.
Something positive or at least non-negative. You add it to 1,000 squared, positive, square root of that, positive. I don't have to worry about undefined. All right, so let's see. Let's do it, algebra fans. It's not just Julia. I could divide by 30. I was thinking about Nope. I was thinking about squaring both sides. 900x squared is equal to 400 times... What? Is that okay?
Oh, never mind. Wait, what did you do?
I squared both sides. Right, because I didn't like the square root. So I figured, all right, let's just square them both. And on one side I'll get 900x squared, I square 20, I get 400, and I square x squared plus 1,000 squared. And actually, check this out. 400x squared, 400 times, I'm going to leave it like that because that seems like a really big number. All right, 500x squared equals... Yeah, where'd that come from?
It looks like a 9, probably.
Oh, sorry. All right, let me...
Oh, okay.
Better? Okay. And I think all I need to do is take 400, times it by 1,000 squared, divide by 500. Oh. What do you think that's equal to? Can you do it in your head? I can. 894 point something.
Oh,
Can you really do that? Yeah. You have that planned out.
I'm
In first period, I thought you were dead.
What is it? 400 times 1,000 squared? Divided by 500.
No, wait, you need the...
It's cool. It'll work out. Hey! Right? That's great, right? So look. What got us? Okay, so coming up with a model was hard. Using our calculator was easy. doing the calculus, I'm going to actually say that was easy. Doing the algebra, I'm going to say was medium. Does that seem right? Okay. And if you look at that, then we said that the easy parts were calculator and calculus. The hard parts were algebra and geometry. Right? Did you really think you were going to get to senior year and say the hard parts are algebra and geometry? No. But you guys, look, top 10%. All right. So, let's see. I can stop.